This is lesson 4.5, Analyzing Lines of Fit. The essential question here is, how can you analytically find a line of best fit from a scatter plot? Now, one of our core concepts that we're going to learn here is something called a residual. A residual is the difference of the y value of the data point and the corresponding y value found using the line of fit. A residual can be positive, negative, or zero. A scatter plot of the residuals shows how well a model fits a data set. If the model is a good fit, then the absolute values of the residuals are relatively small, and the residual points will be more or less evenly dispersed about the horizontal axis. If the model is not a good fit, then the residual points will form some type of pattern that suggests the data maybe it's not linear. Wildly kind of scattered residual points suggest that the data might actually have no correlation at all. So in our first example here, we're going to be using residuals. If you look back in your last notes in example 3 in the section 4.4, the equation y equals negative 2x plus 20 models the data in the table that's shown. So is the model a good fit? The first thing we need to do is to calculate the residuals and then organize your results in a table. And then we're going to use those points to make a scatter plot. If you're looking here, you'll see that x is 1, y is 19. But if you use that formula, that y equals negative 2 times my x plus 20, I'm going to get negative 2 plus 20, which is going to give me 18. So like for my first one, it would be 18. So my residual would be that 19 minus 18, which is going to be a 1. Now I'm going to do that with all the values here. And if you notice, our residuals here, we have 1, negative 1, negative 1, negative 1, 0, 0, 1, 1. So they're all relatively close. But let's go ahead and plot these. To plot these, what we're going to be using is the x and the residual. So it would be like 1, 1. 2, negative 1. 3, negative 1. 4, negative 1. 5, 0. 6, 0. 7, positive 1. And 8, positive 1. So the points are dispersed about the horizontal axis. So the equation y equals negative 2x plus 20 is a good fit. So let's look at another example. The table shows the ages X and the salaries Y in thousands of dollars of 8 employees at a company. The equation y equals 0.2x plus 38 models the data. Is the model a good fit? So first off, we have our original information. Then, using our equation, the y equals negative 2x, not negative, but 0.2x plus 38, what is going to be my residual? I've went ahead and calculated those. I'm sorry, I've obviously put the wrong table on here, but these are the values if you can read them, and the residuals. We end up with some residuals like negative 3, negative 1.4, 0.8, 3.4, 5, 3.6, 0.4, negative 4, and we're going to go ahead and graph those. Remember, we're graphing the x and the residual. So we've got 35, negative 3, 37, negative 1.4, 41 and 0.8. Then we've got 43 and 3.4. And going to continue plotting these points. So after plotting all of these points, you might notice that the residual points form kind of a upside down U-shaped pattern. This suggests the data are not linear. So the equation y equals 0.2x plus 38 does not model the data very well. So finding lines of best fit. Graphing calculators use a method called linear regression to find a precise line of t called the line of best fit. This line best models a set of data. A calculator often gives a variable r called the correlation coefficient. This value tells you whether the correlation is positive or negative and how closely the equation models the data. Values of r range from negative 1 to 1. When r is close to 1 or negative 1, there is a strong correlation between the variables. As r gets closer to 0, the correlation becomes a little weaker. So how are we going to use this with our technology? So you're going to need your graphing calculator for this one. The table shows the duration x in minutes of several eruptions of the geyser Old Faithful, and the times y in minutes, until the next eruption. Using a graphing calculator to find an equation of the line of best fit t, then plot the data and graph the equation in the same viewing window. Then we're going to identify, interpret the correlation coefficient, and interpret the slope and y-intercept of the line of the best fit. So using our graphing calculator, we're going to enter the data from the table into two lists. So your list 1, if you noticed here, is going to be those x values. The list 2 will be those corresponding y values, the time. Now, our second step here is we're going to use the linear regression feature. The values in the equation can be rounded to obtain y equals, notice the a is the slope, which is pretty close to 12. Then we have, so b, which is the y-intercept, is pretty close to 35. So we're going to have the equation y equals 12x plus 35. Now our correlation coefficient is down here at that 0.978. So our step 3 is we're going to enter that equation into the calculator, then plot the data and graph the equation in the same viewing window. The correlation coefficient is about 0.979. This means that the relationship between the duration and the times until the next eruption has a pretty strong positive correlation, and the equation closely models that data as it's shown in the graph here. Now the slope of the line is 12. This means the time until the next eruption increases about 12 minutes for each minute the duration increases. So the y-intercept is 35, but it has no meaning in this context because the duration cannot be 0 minutes. Now, some other things, some other big words we're going to learn here is interpolating and extrapolating data. Using a graph or its equation to approximate a value between two known values is called interpolation. That's like using that line of best fit. Using a graph or its equation to predict a value outside the range of known values is called extrapolation. In general, farther removed a value is from the known values, the less confidence you have in the accuracy of the prediction. So in our example 4 here, we're going to be doing a little bit of interpolation and extrapolation here. If we're looking at our example we just finished here, we're going to use the equation of the line of best fit to first approximate the duration before a time of 77 minutes. To do that, we're going to plug 77 in, use my smaller one, 77 in for my y, and solve for x. So we got 12x plus 35. So you subtract 35 from both sides, then divide by 12, and you're going to get that x is about, it's going to be 3.5. Sorry, not a very good point there. Now, step B, so really what that information is telling us is an eruption lasts about 3.5 minutes before a time of 77 minutes. Now, using a graphing calculator, though, we can graph the equation and use the trace features to find the value of y when x is approximately 5. So you're going to use your trace function and trace along this line. And as you do that, you should get to about a time of about 95 minutes that will follow an eruption of 5 minutes. So your 5 should be about right here, which is going to be your 95. And if you'd use your trace function, you would see that. Now, what about correlation and causation? When a change in one variable causes a change in another variable, it's called causation. Now, causation produces a strong correlation between the two variables. The converse is not true that. In other words, correlation does not imply causation. So let's look at identifying correlation and causation. Now, tell whether a correlation is likely in the situation. If so, whether there is a causal relationship, and then we're going to explain our reasoning. Time spent exercising and the number of calories burned. Well, there is a positive correlation and a causal relationship because the more time you spend exercising, the more calories you are going to burn. Now, what about the number of banks and the population of a city? Now, there may be a positive correlation, but really there is no causal relationship. Building more banks will not cause the population to increase. So this is just a positive correlation, but no real causal relationship. Go ahead, show me your notes, and then get started on your clever assignment.